Hey everybody, it's Rev from Into Gaming. Today's video is going to be the three views, take two. It's a semi-deep dive into client-side prediction. I'm not going to get into the full gamut of details on that. We're just going to give you a brief overview. This particular video is going to be part of a gamer's guide introduction to some of the stuff on the back end of game development. For my regular viewers that are coming from the Unreal Engine community, the actual forums or knowledge base or Reddit or any of the other game dev communities that reach out here and there, yeah, we can say it's for you if you're new to this kind of thing. Client-side prediction across the board is the same in every game engine. It doesn't vary that much. I mean, it's the same principle. Autonomous proxy authority is the server, and you have a simulated proxy. All multiplayer games have this set up. Whether or not they're using client-side prediction, it varies, but most surely every major shooter game on the market that's not indie built will have client-side prediction built into it. If you're coming from Unreal Engine and you're using Unreal Engine's default character class as your base, your parent class, you will have movement client-side prediction set up. So overall, we're going to explain out what the three views are: autonomous proxy authority and the simulated proxy, what that's all about. So it's basically a top-down kind of view of multiplayer gaming, and then we will demystify Desync. A lot of you coming from the game dev community, we call that something else. We call desync something else. We just call it lag because that's what it is. Network lag, computational lag. It depends on what end of the spectrum we're dealing with. For gamers, we'll call it desync because things just don't add up. I'm behind cover. Somebody's shooting me when I'm completely in cover and I'm taking damage. So we get this desynchronization of where I am on my screen versus where I am on everybody else's screen and the server. So that's what we're going to be running through today. I'll be doing a demo using bots, some AI that I set up, some simple little guys. So it'll be a client-side prediction demo for that, and then I'll show it, I'll emulate it in a networked kind of environment here through the editor. So beyond that, before I dive into this, I just want to introduce myself to those that aren't familiar with me, don't know who I am, don't visit my channel regularly, don't know me from the Unreal Engine community. So I'm Rev from Into Gaming. That's my little community that I do for game dev and gaming in general. I'm also the senior game developer and programmer for Rings of Battle. It's an indie battle royale title that's under development. Shout out to the Rob team there. We have Reddit, Discord, sites and forums. They're kind of under development right now, but we have all the community. We got Twitter and everything, so you can find us out there. Just search for Rings of Battle. So shout out to the guys over there. So anyway, I've been into game development at some level since the late 90s. My main engine of choice has always been Unreal Engine. I've been working with it since roughly 2000, the UE 2.0 days. It's at some level I was in there. I was hosted by GameSpy. I ran an Unreal tournament modding and level design community. We were under Planet Unreal through GameSpy's system. From there, I've worked with other engines and games as part of either a modding community or just dabbling with the engine, seeing how it worked and what were the processes with that engine or mod setup, so forth. So we're talking like Battlefield 1942, Battlefield Vietnam on the Refactor 1 engine, Battlefield 2, 2142 on Refactor 2, Call of Duty 1, 2, and 4 in its iterations of engines, did some modding and mapping with in that engine, just dabbling around, see what's going on. Dunia engine, which some of you might know from Far Cry 2 and up. And then there was the Far Cry engine for Far Cry 1. Source engine, Counter-Strike, Counter-Strike Source, Half-Life 1. Haven't done too much with Source Gold. I poked, peeked, and whatnot, but I've dabbled a little bit here and there. So I've been doing this stuff for a long time, 2 decades plus, depending on what your aspect of it. I'm getting to be an old guy, getting ready to hit 50 by the end of the year. So I'm not a young chicken. Been doing this stuff for a long time. Gaming and game dev is what I do. So anyway, we're going to jump right into the client-side prediction of things. Quick definition of it is just client-side prediction is a method to give the client, you, the player, a massive increase in response time. So back in the day when multiplayer gaming first started off, we had Lockstep. It was John Carmack's setup through QuickWorld, where essentially you'd input a command for movement or an action to fire or anything, and it would be sent to the server. The client didn't do anything. It would just send it to the server. The server would get it, process the information, and then send that data back, and then boom, you moved based off what the server said you could do. So if you had a high ping of, say, let's say 80 millisecond ping, it would take 80 milliseconds plus server processing time before, and client-side processing time before you actually moved on screen. So I hit the jump key, and then there's a delay, and then I jump. So it wasn't responsive. Client-side prediction gets away from that, and it allows the actual client to have some level of movement, interaction, and responsiveness immediately on key input. So I hit jump right now. Let me see if in here I hit jump. Where's my jump key? I hit jump. I'm jumping. I'm instantly jumping. It's just like I don't have to wait on the server to get this information and send it back to say, yeah, you can jump, and this is what you would do if you jump. I jump. If I want to move forward, I'm fine. I want to turn and run around, I'm fine. The server does it. I mean, the client does it, and then it sends that data to the server. So in essence, we execute the logic locally. We pack it into the server moves, and we timestamp everything, and then we send it to the server. It travels across the internet, hit the server. So we have a delay there. The time it takes to get it from you to the server, that is a network delay. It gets to the server. The server then says, okay, he's running this character class. So for example, this is my little goofy TPP character class that I'm messing around for demos. Okay, that's the class he's running. Let's load up a copy of that class and then process this logic. Process the inputs at the game times in sequence as they happened on the client. The server does that, and then it says, okay, let's compare where the client said he was by the end of moves to where I calculated. Boom. So at that point, if the comparison is good to go, there's no issue. There's an error margin that we deal with here. If we're inside the error margin cushion, the server says, okay, he's close enough. Let's just send him an acknowledgement, an ACK, that you're good to go. And then move on. And then we pass this data off to the simulated proxies, which is a copy of you on John Doe's computer, or Wacky Jackie's computer, or Massabeer's computer, or whoever else's computer, Roly Poly, if you're out there. That's how this stuff works. So we got all these network delays from you to the server processing time, and then to your opponents so they can run it out. When an opponent gets this data, it does the same thing. It loads up your character class, whatever character class you're actually using, and it processes that logic too. But it's also got in location states that the server had sent it. But your client is actually still loading that character class and processing character logic using the values within that character class. Let me just get out of this and I can give you some of this stuff here. So all this little craziness here, it's a goofy little setup here I got. But anyway, we're going to jump over and look at character movement. So we have all these different values for like jump Z velocity. If this is my character and I jump, this is the velocity that I'm going to be using. Stuff like that. We're using the identical class, so there's not going to be much room for error. That's why we have a margin of error set up, and it's typically pretty small. So that, in a nutshell, is it for client-side prediction. I mean, it's just a roundabout way. I don't want to go through all the technical stuff. If you want the technical and you want a very detailed process of what's going on that anybody can come through and read and understand overall, here we go. It's here. It's documentation. This is for 4.27. I'm running my demo in 5.01, 5.0. It's the latest version of the engine. It's great, although that it did break when I ported. I originally coded everything out for this in 4.26 project. I said, everybody's going to want 5. Everybody's going to say, why aren't you using 5? So I ported my project to 5, and it broke it. So that's one of the things that you have to deal with as a dev when porting and updating your engine, is it can break code. It can break stupidly simple code, and it can break complex stuff. So anyway, if you want this information, links here. I'll probably more than likely post this in the description on YouTube for the video. But we get down into all this stuff. We have the autonomous, we have the authority, we have the simulated, and then we get a step-by-step overview of how this stuff works all the way out. And then we have the replication. Replication, anybody's not familiar outside of the dev community, replication is networking, which Netcode. How do we set everything up netcode wise? We're going to replicate values, variables. We're going to replicate whole components. We're going to replicate movement and so forth. It's all here. Client prediction data, everything you want to know. Handling errors and corrections. And I will go over this real quick. And when you get an error, when the server says, hey, your position doesn't match mine, we're going to send you an adjustment. Here's where you need to be. The server says you need to be here. So it sends back that acknowledgement saying, hey, a response, basically a response RPC, saying, hey, this is where you need to be. Where it lies within that error margin. So if you're getting an adjustment, it means you're outside that little buffer of margin, that error margin buffer. So if it's a small move, like say I just need to move a few centimeters or rotate a little bit and whatnot and adjust my pitch and yaw, or something simple and small and short, it's not significant, it's not huge, that movement, that adjustment will be lerped, interpolated into multiple frames, so it won't be a jarring snap. If it's a large offset, say you were supposed to be a meter to your right and rotated 70 degrees, well, you're going to get teleported. And that's that snap. That's where rubber banding is. And technically, that's 100% rubber banding. Is the server saying, hey, this is where you need to be. You're not currently there. You need to get there. And it does it immediately, and it just teleports. It actually uses teleport node. Let's know it's down here. Set actor location and teleport, and we have teleport node. So this is what's actually happening. And teleport, either of these two functions, is instantaneous. One frame, boom, you're done. Let's see, set move mode. We don't need to go into any of that stuff. But I mean, you can just scroll through this and hit up some of this other stuff, the client server model and networking and stuff. If you're interested in that kind of stuff, my UE guys, you should know this and know where to go for all this stuff. But anyway, so that out of the way, that's just client-side prediction in a nutshell. So what we need to get into is, for this to make any damn sense, is we need to break down a few variables for you, or terms that we use. First of all, I definitely want to cover ping. What is ping? It's so misunderstood in gaming. Got people saying my ping in game sucks, but my I test my ping and I got a really low ping. I have a good connection. Well, if you're going out to speedtest.net or you're hitting DSL reports or something like that, you're not pinging the server. If you want an accurate ping, you have to ping the server, and that's through the IP of the server. And ICMP pinging is not what we do in game dev. The game engine actually has ping calculation code built into it, and it's not sending you ICMP packets. It's not sending you any special packets to determine your ping. It's using already built-in game data packets. So when you do any kind of action that you got to send a packet to the server, well, you're sending every one of those little actions has a timestamp on it of the game time, game world time. So when right now, game time is 0. When I start the game and enter it, we're going to look at the server, see what the server's game time is, and it's going to send a copy, and we're going to adjust out there. But we have a timestamp. It's in every packet that we send to the server. And the server, when it gets that packet and starts processing it, at process start of the packet, it says, hey, what's the current time in the game world? And it says, okay, well, here's the timestamp for current time. We take current time and we subtract your game timestamp from that. And that comes out to a millisecond value, and that tells us our one-way travel time from you to the server. And that's how we get ping. And we set ping at, we do have exact ping, and we have average ping, and we have different ping variables that we have in game, but ping overall is that current time minus timestamp time times 2 to get a full RTT, round trip time. But in general, as you're seeing here, text I got on the screen right now, we don't use round trip time in game dev. I don't know of any game that uses round trip time. We use a simple 50% of ping, because data is only going one way. So either the server's sending you a packet one way, we don't care about the return because there is no return. It's coming to you, or it's coming from you to the server. So it's always one way, so we're only dealing with an update travel time. So ping divided by 2 is your update travel time. Server tick rate. Very confused about that. 30 hertz, 40 hertz, 50 hertz, 60 hertz, etc. That is the server's update frequency, aka frame rate. In game dev, we don't call it frame rate, we just call it tick, because that's what it is. It's the server's tick rate, 30 hertz. The tick rate will be 30 ticks per second. 40 hertz server, 40 ticks a second. 60 hertz server, 60 ticks a second, which gets us down into the server tick interval. It's the length of a frame or tick. If you're in game dev, you'll know that we have a tick event in every actor class within the game. Just about everything in the game is tied into tick in the actual engine. So we have tick and tick events. And off of tick events, we kick the interval out. It's called delta, or delta time. We use this in everything. So anyway, the server tick interval is 1,000 milliseconds divided by the tick rate, or hertz frequency. So you can see the example here. 30 hertz server has a 33.33 millisecond interval. It's time between the ticks, or the time between the frames, or the length of frame, the length of tick, and so forth. And this fluctuates. I mean, you can say the server's 30 hertz, but it's not always executing at 30 hertz. Sometimes if it gets bogged down, it'll run a little slower. And I go to 29.56 or 28.72 or whatever. The more bogged down it gets, the lower the higher the interval is going to get, which affects the overall number of ticks it can process in a second. Anyway, hopefully that's cleared up and there's no miscommunication from that, because we need to know what this stuff is to do these other things that we're about to do. So we got some basic scenarios here. Client 1 has a 30 millisecond ping, client 2 has a 150 millisecond ping, the server tick is 30 hertz, so the total network delay would be 123.333 milliseconds. A scenario 2 would be 300 versus a 30 ping, and that's 198.333 milliseconds worth of delay on the network. The network is your ping, your opponent's ping, or let's say UTT. Your client's, your UTT, your opponent's UTT, and the server's tick interval for the current frame. That gives you your base delays, your inherited delay there. And then there's your client side processing time. There's the game thread, simulation thread, render thread, and then the output from your GPU to your screen and the refresh time. And if that might sound like, I got a beefy, it just pops it off. You also have to take in consideration that the render thread, the last thread in this command, this chain, is actually 1 to 2 frames behind the game thread. So we have that. So there's an inherited delay there as well. So there's a lot more delay than just these 3 base values going on. I don't know if I mentioned this in the beginning of the video, but sending packets, RPCs, and this stuff always starts at the start of a tick or a frame. Always at the beginning of tick. Never in the middle, never at the end. It always happens at the beginning. Then you have your processing. Processing starts at the beginning of a tick. So there's a lot of things that happen at the start of tick. So if I receive a game update from the server in the middle of a current frame, I don't start processing that update until the start of the next frame. Period. That's just how it works. We're just getting into, this is how it works, guys. So with that information all set up, what I want to do here is, let me break this out so I can set some settings here. What we're going to do is do a scenario here. So we're going to start looking at Desync. So I can show you exactly what's happening in Desync. So I'm going to take my autonomous guy. Let's say that the red guy is you, Mr. Autonomous over here. That's you playing on your end. This is your character on your screen. So the red guy represented in this demo will be you. The black character is the server, where the server is going to think you're at this current moment in time. And the simulated is what I'm going to be represented on my screen. We both have 45 millisecond pings. We're just going to go with an NA average, and we're going to set the server to PUBG's actual thing. I like PUBG, and it has its faults, but they've done a hell of a job technically. Technically, if you know engine and game dev, technically they've done a hell of a job with that game. It's a lot harder than you think to do this stuff. So I'm setting the server's tick rate to 30. So just like what they have and what most multiplayer shooter games are running at is 30. And we'll get into why can't you update tick rate and increase it and all that stuff in a few minutes. But I'm just going to give you the base setup here. So this is kind of like the average scenario. I got my 3 guys. They're all kind of synced up there. Boom. I turned on time dilation here so we can see what's going on. And I'm not having to chase these guys. The red player is you. That's where you see yourself at this moment in the world. That's where the server sees you in the black, and the grayish white dude, that's where I see you. And this is all just network lag for the most part, because we're running this on a simulation on a listen server. Excuse me. So this is where all that craziness goes. Let me pause this back. No, I want to resume it, and I'm going to turn them around. I screwed it up. Yeah, I screwed it up, the sequence on that. So, turn off time limit. Get there. Jump. Turn them around. And jump. But that's Desync. And let me just going through my notes here. I have notes. I do all these things live, one take, live kind of thing. So beyond that, I mean, Desync to the point is the sum of all delays, because you don't have a 0 millisecond ping. I don't have a 0 millisecond ping. The server doesn't process data in 0 milliseconds. That's why we get these delays. We can't have a one-to-one representation ever until we start getting at 1,000 hertz servers with zero pings across the board, and that's pretty much the only time you're ever going to see a one-to-one 100% matchup, and that's just straight up physics. So the desync in a nutshell is sum of all delays. The majority of it comes from latency, and I'm going to show that next. The majority of desync comes from latency, ping latency, and packet loss. Packet loss just doubles this damaging little thing over here. Beyond latency, then it's computational. How long does it take your client to render the update, compute it, simulate it, and render it to screen? That's a computational. How long does it take the server to compute all these things for every player and every actor that's in the game world, like 50,000 actors and so forth? How long does it take to do that every freaking tick and get that information passed off? So in a nutshell, it's delays. So let's break some myths here. Everybody says let's bump this up. So bump the tick rate up to 60 hertz. So we're going to bump that tick rate up, and then we're going to play it. We're still not one-to-one, and we're just dealing with 45 millisecond pings. All right. Let's say let's take let's take the simulated guy. Actually, let's do this. Let's give the autonomous guy. We're going to give him a 15 ping, and we're going to take the sim guy, and we're going to give him a 300 ping. That's your VPN guy. Actually, let's do in EU. Let's go West Coast guy, sending him over to the EU region. Well, I'm going to give him a 120 ping and see what that looks like on a 60 hertz server, not a 30 hertz, a 60 hertz server. Alright, fellas, boom. And what do we see here? Low ping guy is real close. The autonomous guy, he's real close to the server because he's got a stupid. So that's somebody that's living real close to the EU server. The server is pretty tight to where he's at. He's not 100%, but he's pretty tight for the given moment in time. The guy coming West Coast EU, he's lagged out. He's way behind what the server says. So let's modify that out again. Let's say it's somebody in Asia VPN into the US with a 300 ping. That's kind of ballpark. And still on a 60 hertz server, which is twice what we're doing in like PUBG and so forth, in Warzone and Fortnite. Fortnite, I believe, runs on 30 hertz as well. That's a 300 right there, the simulated. That's how much desync there is. And that's just network lag and a little bit of computational from the server. That's just gross. Okay, so what do we got to do to get these to match up 100%? Alright, let's say we're going to go 120 hertz server, and I'm going to give you one ping and one ping. Or actually, let's just do 0 and just cut to the chase. 0 and 0 in a nutshell. 120 hertz server, which has a 8.333 millisecond interval, and both players in this scenario have 0 ping. Boom. And I'm going to pause this, eject out, and then resume. We're still not 100%. And you won't get to 100% until that server tick rate is 1,000 hertz. And the client that's playing the game, his computer can run at 1,000 hertz, 1,000 FPS, with no 1% lows, 1,000% across the board. He's just nailing it, or 1,000 FPS across the board. You will never get a 1-to-1, and this, you can't do this. You can't even do this on LAN. So on a LAN, you're dealing with a 10 and a 10. So let's go back to default tick rate. So this is what LAN looks like, your average LAN. That's your average LAN. 10 pings across the board for everybody. And that's if the server is actually in the same room. So if you have a bunch of conference tables set up in a circle, and you got the server is sitting in the middle of those tables, and you're all networked there, that's what LAN looks like. Now, if you're doing some crazy PUBG LAN where the actual server is not in the room, it's not technically a LAN. The people there are all grouped together. They're in a LAN environment, but the server's not. It's going to be a little bit worse than that. But yeah, general LAN servers in the same room as the players, and you're directly networked right there by physical cables directly to the server and the network hardware. So anyway, that's that. So this thing is getting pretty long. Sorry about that. Details, you got to have the information to understand what's going on. I don't want you walking away from this and assuming, oh, just update the server stick rate and we'll be fine, or add servers. You know, that's just a different topic. Not everybody or not every game can actually add servers to make things better, or more servers. It's just not a thing. I'm going to leave that at 30 for this next thing. We're going to go into multiplayer setup here. Net mode is play on client. We were just doing a listen server kind of setup. And now I'm going to do this too. And let's see. I want to do net. Yeah, I think it's net dot. Net emulation. Yeah, no, it's just net emulation. Net emulation dot packet lag 0. So we're setting up everything. I got the two guys here, and let me make sure I get this net. Let's just net emulation dot off, and I want to do it on this guy too. So we're not running any kind of crazy setup. I want to start off everything at 0. Emulation dot off. So basically, when I jump or make a move, I want it to instantly happen. So there's still a delay there. Let me restart this. Maybe this will do it. Yeah, there we go. I just had to restart it. So I'm controlling the guy on the right. So I go over here and open up this door. As we got network doors. Well, I've been prototyping perfectly network doors here. So here we are. Let me pop off in the third person. Actually, move over a little bit. So we can see characters clearly. I'm going to jump, and the jump is perfectly synced because both players in this simulation have 0 ping to the server. The server is actually running on the same system, so there's 0 ping. So what I have to do is do net emulation, and we're going to do that packet lag. And what was our values over there? What we were doing? 123.333, I believe, was our first scenario kind of setup. 123.333 of network delay. So now, when I jump, there's a delay, and you can see it. And let's go over here and see which one this was. This was the 30 versus 150, and this is the level of delay that you're going to get, not counting client processing and so forth. So there it is. It's best to just do it with the jumps so you can see it. So let's just look at that other crazy one real quick. I'll do net. Actually, just bump that back. All these commands. Net emulation. The other one was 198, I believe. 98. We're going to play that, and it's just going to get worse. It's just going to get worse. So what does it look like with 2 300 pingers popping off? let's just give net, back that just up. Let's give it 333.333. That would be 300 players on a 30 hertz server. And that's just disgusting. It's just like you do a peak. And you can see that delay. Oh. Client-side prediction, which it doesn't lead to desync, but I mean, desync's always there. You just have it in different formats. So if you're either using client-side prediction or you're using lockstep, you're just going to have different varying payoffs and cons, so pros and cons to it. With lockstep, you don't get that instant, I press the key and something immediately happens. With you just, it's just completely delayed, kind of like a door does when you're at this kind of ping. There's that delay, because most of your game interactions, see, the server owns everything in the game world. You just own your character and your controller. That's it. And the player controller is this mystifying thing in the back. You pretty much, when you spawn, when you join the server, it creates one for you. You have a player controller, and that is used to emulate you into the world, and you just control a pawn or you control a vehicle and so forth. So everything else is owned by the server, and if you want something to happen, like open a door, you're basically just saying, hey, I just interacted with this door, tell the server to open the door. So you're sending a packet to the server says, okay, let me verify this or validate this action. Okay, now I'm going to execute it, and then it opens the door. So that's why we're seeing this kind of delay right here that we didn't have in the other setup. Let me see if I can get my screen to hit the thing. Yeah, there it is. There's the delay. I'm clicking this thing, and it just takes forever. So if I go back in here and set it to 0.0 and then try it, if I can get it's instant. There's no delay if I hit it right. But there's literally no delay to it. So for the most part, a lot of things that we do in game dev is like we'll do a client-side fakie kind of thing. Like for doors, we'll process an animation. So the hand reaches out to grab the door when you do your interaction. If you're going to pick up ground loot using the default F key kind of thing, you're going to actually do an animation for that. And that's where we get these delays, where we're sending these packets off. We're firing off the packets to go to the server, then we're starting the animation. So the client is actually doing something. It's responding to your input. And we kind of fake that out. We do that with shooting. We do that with loot. We do that with doors. We kind of do that with windows too when you bust through it. So a lot of this stuff is based around client-side prediction, giving you response, an instant response to your action. So that's what client-side prediction is. Hopefully we know what desync is now. We've gone through the technical. If you want that stupid dirty technical, you can go over and look at the character movement and actually read through client-side prediction and just understand that internet time, you have to send data from one point to the other point. It doesn't get there instantly. It's not instantaneous transmission. So that is a delay, and that's going to be represented in the gameplay. There's no way for us to lag comp that out so you don't see that delay. It's against physics. You just can't do it. Let's see everything else. Everything. Yeah, I think that covers it, guys. Got the lockstep breakdown. Yeah, I think we're good. Just breezing through notes and everything. If you have any questions, hit me up on the YouTube channel. You can hit a comment, or you can actually join the Discord, or find me over on Rings of Battle and hit me up there. We're on Reddit, Twitter, and let's see, we have a forum. I don't know if he's set up anything with TikTok or anything, but We're in all the major places. We've got the Discord and so forth. So be looking for you. Like I said, thanks for watching. Any questions, just hit me up.